Welcome to Precalculus Concept 13a, Polynomial Functions and Their Graphs. Today we're going to talk about how to identify and recognize characteristics of polynomial functions. There's 4 boxes. So here's the first idea. This is where our journey begins. We want to figure out what makes a polynomial function. So what defines something as a polynomial function? So it's going to be in the form of f of x equals something. And there is this first part out in front, and then there is this part up here in the exponent. So let's talk about these things individually. And of course, this could be added on and so on and so forth, but they're all going to take the same effect. Basically, the first part here, this a sub n part, is not allowed to be 0. So a sub n is not allowed to be a 0. That's our first idea that we have to have. And it can be any real number that we want. So a sub n can't be 0, but it can be any real number. Okay. This part up here, this n, this exponent, these are our exponents, and these have to be positive integers. And the way that we describe positive integers is this funny looking z, and we put a little plus sign. So positive integers have to be up that. So this is what defines a polynomial function. So the first part, our leading coefficient, has to be any real number that's not a 0, and our exponent part has to be any positive integer. As long as those two criteria are met, then we can start talking about polynomial functions. Okay, in box number 2, I have 4 examples for us to talk about. 4 functions here. I have f of x in number 1. Number 2 down here I have g of x. Number 3 I have h of x. And number 4 I have p of x. So what we're going to do is we're going to talk about each of these individually, and your job is to come up with an answer of yes, this is a polynomial, or no, this is not a polynomial. So let's zoom in real quick here, and let's talk about number 1. It says f of x is negative 3x to the 5th plus the square root of 2x squared plus 5. So right now, do you think this is yes, a polynomial function, or no, this is not a polynomial function? The answer to this one is yes, this is a polynomial function. The reason is because each of our leading coefficients, or each of our coefficients here, these are all real numbers. So all of these are real numbers. And each exponent is an integer. This can be represented as 5x to the 0. So as long as these two criteria are met, then we have a polynomial function. This is a polynomial function of degree 5. So it is to note that this is a degree of 5. It is the largest exponent that we see. So this is a degree 5 polynomial function. Okay, here's number 2. It says g of x is equal to negative 3 times the square root of x plus the square root of 2x squared plus 5. So what do you guys think right now? Yes or no, this is a polynomial function, or no, this is not? Okay, no. The answer is no. This is not a polynomial function. The reason is, you guys, because of right here. You have to recognize that this can be written as negative 3x to the 1/2 power. So because our exponent is not an integer, this does not meet the requirements of a polynomial function. Okay, here's number 3. h of x equals negative 3x to the 4th times x minus 2. What do you guys think? Yes, this is a polynomial function, or no, this is not? Well, the answer to this one is yes, you guys, because if I simply multiply negative 3x to the 4th by x minus 2, I get negative 3x to the 5th plus 6x to the 4th. So therefore, this is a polynomial function, and it is of degree 5, because my highest exponent is a degree of 5. Okay, last one, number 4. P of x is negative 3 over x squared plus square root of 2x squared plus 5. Polynomial function, yes or no? What do you think? So the answer to this one is no way, because I could rewrite negative 3x squared as negative 3 times x to the negative 2. Don't forget your properties of exponents. When you have a positive exponent in the denominator, it can be written as a negative exponent in the numerator. So therefore, because I have negative 2, it's not a positive integer. Therefore, it is not a polynomial function. Box number 3 is simply a picture of graphs of polynomials versus graphs that are not polynomials. All the graphs on the left-hand side, these two, these are polynomials. We want smooth, continuous graphs. So what we mean by this is we have a nice, smooth, continuous curve on both of these. Even if it goes up and down and up and down, it's nice and smooth and continuous. Over here on the right-hand side, these are not graphs of polynomial functions because they have a disconnect or a break or a sharp corner or an edge or something that is not smooth and continuous. So again, the ones on the left, these are polynomial functions. These are graphs of polynomial functions. On the right, these are not because they have breaks or disconnects or some kind of a non-smooth component to their graph. Okay, let's see if you've learned. Box number 4 is a you try. Is this the graph of a polynomial function? Yes or no? What do you think? Hopefully you got the right answer and realize that this is not, because it has a corner to it. It is not smooth and continuous. So this particular graph does not represent the graph of a polynomial function.